All right, so in this podcast, we are kind of changing gears completely. All right, so in this one, when we name the compound, we're going to take the first nonmetal written with a prefix matching its subscript, followed by the second nonmetal written with a prefix matching its subscript, whose suffix is changed to "ide." So when we have two nonmetals, they will always just be two of them, so it's binary. And again, when it's binary compound, it always ends in an "ide." So there's some prefixes you need to learn. So number one, we use the prefix mono. And number two, we use the prefix di. And three is tri. And four is not quad, but it is tetra. So the game Tetris, all those shapes are four squares arranged in various arrangements. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. All right, and this naming is really easy. So if you think about it in terms of charge, if we have nonmetals with nonmetals and all their charges are negative, will it ever add to 0? And the answer is no. So right now you're not going to worry about this, but these bond in a completely different way than ionic compounds do. So ionic compounds, you have a cation, which is positive, and an anion, which is negative, and their charges have to equal so that the compound is neutral. The way these compounds, which are known as covalent compounds, the way they work is they share electrons instead of transferring electrons. So this is all second semester related stuff, but here we go. This first one, actually, we're going to look down here with these asterisks first. Only use mono for the second element. So you might write that in first for the second element. Otherwise, we'd be using mono a lot because a lot of compounds don't have but one of the first thing. All right, so PF5, we have phosphorus. So phosphorus. And then our next compound is fluoride, but we have 5 of them. So we're just looking at the subscript. So we have phosphorus pentafluoride. And again, fluorine is a U before O. Otherwise, you have flourine, just like what you bake with. Okay? So phosphorus pentafluoride. Easy peasy. Next one, we have nitrogen. All right, then we have 2 oxygens. That would be dioxide. So how do we know that this is not nitrite, right? The polyatomic ion we memorized, it was that. Well, because it's an ion, it has a -1 charge. And notice over here, this has no charge. So because it's neutral, it's not the polyatomic ion, NO2, but it's a compound nitrogen dioxide. Next one is NO3. Again, not nitrate, because there's no charge there, but this is nitrogen trioxide. Okay, how come? Because there's 3 O's instead of just 2 O's. And I'm sure you can kind of see how this works. Next one, pentaphosphorus. These can kind of get tedious writing because they take a while to write out, but there's not really much thinking involved. You just have to memorize the prefixes. And then decoxide or decaoxide. Typically, if there's 2 vowels in a row, we just kind of combine them to 1 vowel. So you can say decaoxide, decoxide. Either way, I'm not real concerned about spelling if you have 2 vowels in a row. Okay? And then this last one is kind of where this rule comes from right here. So we have carbon. And how many oxygens do we have? Ooh, we don't have carbon, but carbon. All right, and because there's only 1 oxygen, we use mono for the second one. So it's carbon monoxide. And notice here we don't say monooxide, but monoxide. So we just take one of those O's and drop it out. So again, this very last one, CO, is carbon monoxide as opposed to carbon dioxide, which would be CO2. And you can kind of see how naming works for covalent compounds as opposed to ionic compounds. All right, so at the very bottom, writing the formulas. Change the name to a symbol and match the prefix with the subscript for both elements. So this is really easy. So I have dinitrogen pentoxide, so I'm going to write nitrogen. I have 2 of them because it's dinitrogen. And I have oxygen with a 5. Okay, next one, diphosphorus, so P2. Heptafluoride, so I have fluorine and 7 of them. Next one, CO2, carbon dioxide, and tetrasilicon, so Si with a 4. Octabromide, so Br with an 8. All right, so kind of saving some easy ones towards the end. That certainly doesn't look like an 8. So there we go, a little bit better. So C4, Br8. All right, so that is that podcast. Really, really easy. Next one is acids and bases. Or not really bases, just acids.